Hello again. My name is Ricardo Zanini, and I'm a software engineer. Today, I'm gonna talk a little bit about the mounted maps and mounted config maps on Kubernetes, and then how that is we found a bug in our code that was because how the config maps are mounted in a pod. So, for that don't know how that works, when you mount a config map in your pod, a few things happen. So let's try to SSH into this container and see how that works. So my my configuration map is mounted into this volume here, like source, man, resources, workflows. All right. So as you can see, my configuration map has one entry that is this file here that has my workflow definition. And it is actually not the file itself, but a symbolic link to this data greeting JSON, which is in turn is another symbolic link, which is in turn it is in this directory here. So what we have is um, this directory and like a symbolic link into that. So if you go into um, OS and I'm trying to let's fetch, let's see what is inside this directory here. You see that's the original file, mounted from the configuration map. Sometimes a few applications and software out there that is mounted in this in the pod might not deal that with that, because of reasons. In the case that I'm discussing right now, it is like our application. We're like trying to read both files. The symbolic link one, this one, the greeting JSON file inside the workflows directory, and also the other one inside this hidden directory here, and that was causing a few issues. So what we did was to fix it as a bug. Um, we deal with that avoiding reading hidden files and hidden directories inside a given directory with resources. So that how that works. Every time that we run the application, we read for the resources inside this directory here, and we try to mount that to create code in order to execute these workflows in here. That is defined in these files here. So since we have two files essentially, one in the root path and the other one inside the hidden directory that mounted by Kubernetes, we had a bug. So after fixing that, because Kubernetes usually updates automatically a configuration map file inside a pod. So if you change, for some reason you change the file, Kubernetes will just refresh the volume, refresh the file that is mounted in here, and your application can read the file updated. So let's try doing that. We have this serverless workflow definition here, and I have an object that I created. It's called greeting. There is essentially a definition of a workflow in Kubernetes object. So you can see the states in here, and there is this few information in here in this in the node, in the suite case in the node. We have data condition, and we have if it is in English, we say this. If it is in Spanish, we say this, and if it is in Portuguese, we say this. So for this, I'm gonna just update my YAML definition here, my workflow definition. Saludos desde JSON workflow. Once I do that, my operator will update the configuration map that backs up the workflow definition based on that Kubernetes object. and you can see that the configuration map has updated. And if I go to the application and I try to execute it, after a few seconds, you can see that the application has changed. The information in the workflow definition has changed. So I can execute that again. You see that it's super quick because the application has the cache of the definition in there, so it doesn't need to execute or to rebuild that again. And also you can see that the pod is running for quite some time now, like an hour ago. There is no pod refreshing or deleting the pod or anything like that. The pod's there. It is running. As you can see, what happened here is that Kubernetes updated my volume. So if you go to the pod and we try that again, like let's try to do a cat. Yeah, this, let me try something different. To see if there is any changes in the file. You see that the file is updated with the same information that I have there. So let's try that again to see how that works. If that works again, of course, should work. So let's try change that again. I put the number 2 here in this message, in the Spanish message. So let's try to see update. All right, let's take a look in the configuration map that backs up this object here that has the actual definition. You see that the grid in Spanish, let's see, where are you? Yeah, is changed with the number is 2 here in front of. Alright, so after that we can go to the pod again and see if there's any changes. Let's try to do a cat again. Yay, there is a change. You see? Oh, I'm sorry, no, there is no change yet. So we can wait a little bit. In my test, like Kubernetes takes a few seconds to update the configuration map. So like it varies, like 30 seconds, 40 seconds, 15 seconds, depends on the watch algorithm. So this is the nice part. There is a strategy in the Kubelet configuration, whereas you can change how the configuration map behaves, and how that how you can update the configuration map. How the Kubernetes API can update the configuration map. So here in this sentence they explain the documentation that you have like watch, TTL based, or redirecting all requests. That's the 3 ways of changing the configuration structure of the ConfigMap as soon as you change it. Let me try to clean that and see. Yeah, you see after a few seconds we have the configuration map changed in our pod, and I'm still here SSH into the pod. My pod didn't have to refresh or roll out or any other things, like let's say a brute force into the pod in order to have the configuration map to update. And let's try to execute the application again. So instead of saludos, I'm expecting to see like saludos 2 here. So yeah, the application is kind of doing the changes, and now you can see the change like in here. Yeah, and what is Kubelet configuration script? So it is essentially a Kubernetes object you can configure using kube ADM. I don't know how to pronounce that exactly, but it is. You can take a look in this in the documentation here. I will share these links in the video description, so you can take a look and see it by yourself and try it in your environment. So yeah, here's the documentation about that. So there is a Kubelet configuration script. It is essentially a YAML file like every object in Kubernetes, where you can add that configuration MC here, ConfigMap. Let's try to find it. Okay, so this is the configuration that we need to set, like config map and secret change detection strategy. So you have like get, cache, and watch. So you can play around with this configuration and see what fits better your environment. By default, it is watch. So what means Kubernetes keeps watching the object, and every time there is a change, that change is propagated in the cluster. So in this case, what happens is that we change the config map via the operator. The Kubernetes controller goes to the config map and updates all the volumes that the config map is mounted into. So it is super cool, and you just have to make sure that your application is capable of reading the state of the file. So if that gets updated, your application propagates the update to the application itself. So for instance, a configuration file or any other things. Like in this case, we are using this file as a definition for a running workflow, right? So yeah, and make sure that your application can handle what I said, hidden files, like this case here, that we have all those hidden files and directories. That is like an internal structure that Kubernetes does in order to have the definitions for to control where to update the file or not. So if you change the config map, if you come here to the volume and see if there is a change. If there's not, it will change. Those kind of stuff. I don't know, of course, all the details of the implementation, but that's how it works. So make sure that your application first can handle hidden files, and also can handle the file updates that config map that the Kubernetes controller will do. All right. So yeah, that's all I have today. Hope to see you in the next video, and goodbye.